Welcome to Old Iron Machine Works. This is part 2 of the Big Chuck cleanup. If you haven't checked out part 1, you may want to check it out first. Otherwise, I hope you enjoyed the video. Let me know what you guys think about splitting the videos into 2 parts when I do have a long video. Anyway, here I'm setting the part on some aluminum screen. Just so if it happens to move around, the expanded metal will kind of scratch the parts, so that's why I put that aluminum screen underneath it. But here I'm just kind of cleaning the parts up, ready to assemble. Right here it's got a pretty sharp edge where it connects to the back half of the chuck. So here I just take the file and I just knock off that sharp edge. Okay, I got everything pretty well stoned here. Looking pretty good. Gonna go in here with my Fordham tool and put a polish on here. And there's a little lip right there where they made this cut. It left just a little edge there, so I'm just going to go ahead and just kind of smooth that off, and I think this one's going to be ready to go. Here I'm using a flap disc, and you can see it looks like it's throwing a lot of material off, but just putting a nice little polish on it. Most of the material is coming from the flap disc itself. For you guys that have watched my videos before, you've seen me use this wash cabinet a lot, and then I have basically the same cabinet at home also. But it's just hot water with a big pump and nozzles inside, and then kind of a non-corrosive detergent soap, that just cleans the parts nice. And to me, I'd kind of be lost without the cabinet. Okay, I mentioned earlier when I machined that hub, I got about a 2000 interference fit. And here I'm just heating up the back side of the chuck in order to drop it on. Anywhere from 150 to 200 degrees is all you got to do to get it to drop on. I don't like the pressed cast parts like this on because it's too easy to shear a little bit of material off. So you get a much better job. Just heat it up, drop it on, and you're ready to go. Okay, here you can see it dropped right down metal to metal like I wanted it to. And there's an old clip where I was using those valve parts for a little spacer when I had to make the transfer punch. But anyway, there we are. It's all dropped down and shrunk and nice and tight. Ready to add some grease and put it together. Now those three center bolts are 5/8 bolts, coarse thread, and they're the only bolts that hold the chuck to the adapter plate. Here, just like any other scroll chuck, they're all going to be numbered, you know, to tell you what spot they go in. Another nice thing about this particular chuck is the top jaws, not only do they reverse, but you can unbolt them from the inside holes or the outside holes. Maybe a little hard to tell by the picture, but these bolts that hold the top jaws on are actually 3/4 coarse thread. Now this is a natural gas compressor valve, and it's kind of one of the motivators for getting me to get this chuck together and on my big lathe. I do a lot of compressor valves at work, and in order to try to free up more time for me to be able to work on other projects at work, I'm now bringing a lot of valves home and machining them in my home machine shop. Um, so anyway, that was kind of a big motivator to finally finish this project up. That hole I was just pointing at takes a grease fitting. Although you don't pump grease on the scroll, it'll just get oil. The grease on the teeth are okay because they're pretty protected from chips and swarf. But the scroll, you put grease on it and it just collects all kinds of stuff. Now this chuck, there's absolutely no adjustment like a Just True chuck or anything. Once everything's bolted up and you put it on the lathe, whatever you got is what you got. So I felt like I gave it the best shot I could on making the adapter as most accurate as I possibly could. And the rest of it was going to kind of be up to Cushman themselves. How accurate did they get the chuck when they built the chuck? And at the end of the video, I was pleasantly surprised to see just how good of a job that they did do. Here I'm just rolling some plate. One of my early videos, I posted how I get my big chuck on my lathe. So right here, that red saddle is for a 20-inch chuck. Being that this is an 18-inch chuck, I needed to make just a little spacer that sat on top of the other one, and you'll see later in the video it being used. And here I'm showing the track system that I built for putting the big chucks on the lathe. I know I've mentioned in a couple other videos, this lathe is a 1961 Regal LeBlond, and it's got a 26-inch swing. You might want to check out the older video where I show building the components, for putting a chuck on. But I basically have a lift cart that just lifts the chuck up and sets it right on that cradle. And then now I'll just pull the pipe out, and the cradle is adjusted to where, the height is, height and everything's pretty well perfect. So I just slide it over, slide it back, and get the nut started. I do have a sky hook that attaches to the tool post, but this chuck here is now 310 pounds. The sky hook this lathe would handle it, but it's getting pretty heavy, in my opinion, to be hanging a 310 pound chuck on the sky hook. Now this is an L2 spindle or long taper spindle, and I got it adjusted to where once I start to tighten the nut up on the spindle, it kind of sucks the chuck up off of the little saddle, and then I just pull it out. Now I got it mounted nice and tight on the spindle, so I'm just tightening up the 3 bolts that actually bolt the chuck to the adapter plate. And now that brings us to the part that I've been waiting for a long time. I was always hoping that this chuck was going to be within at least a couple thousands. And what I have here is I have a few different wrist pins. They are used wrist pins, and you can see they're pretty good size ones, but they're actually in pretty good shape. And it's the only thing that I have that I know is, is real accurate. And here I'm just kind of turning it as I snug it up a little bit. And as you'll see in the video, I was pretty shocked on just how accurate the chuck was. Okay, I got my dial indicator set on the end of the shaft, and I'm just taking my finger and I'm applying a little bit of pressure just so you can see that the indicator is not bottomed out. And as you can see, kind of shocking how accurate it's actually running. I give Cushman a whole lot of credit for how they can even do something like that accurate. Now here's another smaller wrist pin, and I wanted to put it in, because to me, every diameter can change how accurate the chuck is. Unfortunately, I would have to unbolt 3 of the chuck jaws in order to have it squeeze that tight. So here I'm just loosening it up again and just kind of spinning that wrist pin. And I find if I kind of, spin it as I'm snugging it up, it really centers up real nice. Okay, that's the large wrist pin I was using. And now I got one, oh, I forgot what size it was. What do we got there? 3 inch, just over 3 inch. And I pretty much got the same results with it. When I spun it, as I was tightening it up, it ran just as accurate. Okay, here I'm showing a little larger compressor valve, and you can see all the void areas in it. And that's where the 6-jaw is going to work great. When you're clamping up these valves with the 3-jaw, you got to be kind of careful, because you just don't have a lot of support with all those voids. So with this 6-jaw, you know, lots of contact points, and it's going to hold the valve really nice and not squish it and distort it. I appreciate you taking the time to check out my video, and if you like these kind of videos, hit the subscribe button. If you like the video, give it a thumbs up. Every little bit helps, but once again, I appreciate it.